In this section, we're going to be talking about logarithmic functions. So we're given the definition here in this blue box. The important thing to realize and get from this is how to change an exponential to a logarithmic and vice versa. So if you look at this part right here, this is the important part. You have y equals log base b of x. That's how you say that. In an exponential equation, you have the base raised to a power is equal to some number. These correspond. The base is down here for a logarithm. The base is here for an exponential. Once you establish the base, to remember how to write from one to the other, you go across the equal sign. So here you start with the base b raised to the y is equal to x. That's how you get over here. Base b raised to the y is equal to x. If you're trying to get to the logarithm form, you identify the base and you say log base b, go across the equal sign, of x is equal to y. Memorize these two forms and that they're equivalent to one another because you're going to use this throughout this chapter. So this is very important. It's so important that they probably will put this on the test. Just knowing if you can convert from one form to another, that's worthy of being on the test. So make sure you know how to do this. So here are some examples. So rewrite each equation in exponential form. So you can clearly see that these are logarithms. Number 3, you have an ln. That is a natural log. So a couple of things. Log normally has a base of 10. So if there's nothing written, if it's just log of x, that base is a 10. It's understood to be a 10. You can see in number 1 we have a base of 4. So if it's anything other than 10, you have to write it. If it's a base 10, you don't write the 10. It's understood to be there. In a natural logarithm, like in number 3, there's no base written. That's understood to be an e. So an e goes with a natural log. Okay, so now we're going to use that information to rewrite. So first, identify the base. The base in number 1 is 4. So we're going to write 4, go across the equal sign. 4 raised to the m is equal to, go back across the equal sign, q. That is it. That's all you have to do. That's what they're asking for in this. Just rewrite it. All right, and number 2, there is no base written. Since it's a log, it's understood to be 10. So we're going to say 10, go across the equal sign to the t, is equal to v. That's it. Number 3, identify the base. There's not a base written. Since it's a natural log, it's understood to be base e. So we're going to have e raised to the n is equal to w. That's how you rewrite a logarithmic function into an exponential form. So now in 4 through 6, we're going to take the exponential form and rewrite it in log form. Same idea. Identify the base. So then you're going to write log base 4, go across the equal sign of y is equal to x. The base should be a little small number. It's a subscript. And the y should be the same on the same level as the log. So I have in number 5, identify the base. The base is 10. So I'm going to have log base 10 of b is equal to a. Now you should not leave the little 10 there. So you should write log of b is equal to a. The 10 is understood to be there. I wanted to write it at first so you see where it goes, but don't write it in your answer. All right, identify the base. It's e. When you see e, you need to use natural log. If you use the regular log, you won't earn credit because you need to know that natural log goes with e. So the natural log base e of h is equal to k. Again, the e is understood to be there, so you shouldn't write it. So you should just have the natural log of h equals k. Solve for x by converting the logarithmic equation to exponential form. So anytime you're trying to solve a logarithmic equation, if it gives it to you in log form, it's often helpful to change it into exponential form. So it might not tell you that, it might just say solve. You should automatically think that. So when you start with a logarithm, start by rewriting in exponential form. So identify the base, that's 3, raised to the second power is equal to x. Well, that was very helpful. Now I know x is 3 squared, which means x is 9. Okay. And number 8, same thing. You start with a log, so we're going to identify the base. It's e. So e raised to the second is equal to x. So x is e squared. You do not have to give the numeric answer for that because that would be an estimate. If they asked you to estimate, then you could put it in your calculator and find a decimal approximation and give that as your answer. All right, use the definition of common and natural logarithms to simplify. Here is a few things that you should know. So anytime you have the log, let's say of base a of a, that's always equal to 1. So if you can get the base and what you're taking the log of to match, you will always get a 1. So for natural log, since the base is e, if you take the natural log of e, that's also 1. They want you to keep that in mind in order to simplify. Remember that you're going to have a calculator, so you could use a calculator to just type these in and make sure your answer is right. But this is, what you need to know. If you have a natural log, e to the natural log of some number, that's always going to be whatever number it is. It's always going to be x. So let's try to rewrite these. So this number 9, we could write this as the log. We really want the base, which is understood to be 10, to match what we're taking the log of. So 100 is 10 squared. Right? To the 8th. So that would be the log of 10 to the 16th. And then since the log of 10 to the 10, those match, that will just be 16. This 16 comes down in front and multiplies by the 1. But in essence, you just get the exponent. That's what's left. All right, here, anytime you have e raised to the ln, it's always going to be whatever was in the exponent. So that will just be 1.06. Okay.